So we also need to be able to solve logarithms, and we're going to do something called exponentiate to do that. Now the idea with exponentiate is that you're using the Tetris effect. You're creating the Tetris effect yourself. So here you'll see that I have the natural log of x equals 3. Now you should remember, if you don't already know, that the natural log is base e. Okay, so whatever you have, no matter what's going on, if you see a natural log, you're automatically having base e. So if I want Tetris effect to happen here, I need my base of the exponent to be e, because I already know the base of the log is e. So what we do with Tetris, or what we do with exponentiate, is we now create this to be an exponent, and we say the base is e, so that we have Tetris effect here. Okay, so what I'm going to do is I'm going to do exponentiate, and because I want base e, I'm going to use e as my base. So let me rewrite this. This is e now to the natural log of x equals e to the third power. Okay, so now I have it in exponential form, and because I exponentiated, and everything that was right here, everything that was right there is now as exponents for my base. Okay, so now over here I have a Tetris effect because the base of the natural log is e and the base of my exponent is e. So my answer there is just going to be an x, and over here I have e to the third power, which you would need a calculator to figure out, but this would be my answer on this one. So let's look at another. Okay, you'll notice here, if I look at these, I have a log base 3 and I have a log base 3. So technically, I don't even have to exponentiate, but we're practicing that. So I'm going to take, and because it's log base 3, I'm going to take and have my base of my exponent be 3. So now technically, I have 3 to the log base 3 of 5x minus 1. And then over here, I have 3 to the log base 3 of x plus 7. And so then these cancel out. I just get 5x minus 1. These cancel out. I get x plus 7. And then I go ahead and solve like I normally would and divide by 4, and x equals 2. And so there's my answer. Of course, you always want to check that 2 as an answer works, and it doesn't ever give you a negative or a 0 inside the logarithm, because no logarithm can be negative or 0 right there, as we've seen when we look at the graph. Okay, another example. Okay, now this one, I can't exponentiate until I have just logarithms, and just this logarithm, just this logarithm by itself. I can't have anything else going on. So I need to get rid of the 5, I need to get rid of the 2. Okay, so then we get rid of the 5. I'm going to subtract 5 from both sides. So now I have 2 natural log of 4 equals negative 1. I divide by 2. So now I have natural log of 4 equals negative 1/2. Now I can exponentiate. Remember, natural log is, where did I get the 4 from? This is an x, right? Okay, natural log is base e, so to exponentiate I need to have an e here. Okay, so that means I have e to the natural log of x equals e to the negative 1/2. Okay, so these use a Tetris effect, and I get e to negative 1/2. Whatever that is on a calculator is your answer. One more example. Remember in the last example I told you I could not do I could not exponentiate until I have just one log, and notice I have 2 logs here. This is not okay. So I have to deal with the fact that I have a plus there. Now if you haven't yet watched the properties of logarithms, you're going to want to watch that to understand what I'm about to do, but I'm going to assume you have seen that. And so what I need to do is I need to get rid of that plus. Using my rules for plus of logarithms is to multiply those. Okay, so now I have log base 10 of 5x times x minus 1. Now this is the most important step. If you can't do this step, you'll get the entire thing wrong. Okay, so once again, you're using your properties that you're adding logarithms. I need it to be 1 log before I exponentiate. I cannot exponentiate 2 separate logs with a plus. Just like when you have this, x plus 2, you can't distribute a squared because there's a plus in the middle. It's the same thing here. There's a plus in the middle, so I can't do the exponent. I need to get them together, so I use that property where you multiply them. Now that I have 1 logarithm, now I can use my Tetris effect, so it's base 10 for both of them. This will exponentiate, or sorry, Tetris effect. So now on this side, I'm going to multiply through by the 5x, so 5x squared minus 5x equals 10 squared, which is 100. Okay, move that 100 over, so 5x squared minus 5x minus 100 equals 0. I'm going to take a 5 out so that I can double bubble this. Okay, and then I can box it out. So we're going to have x minus 5x plus 4 equals 0. I solve at x equals 5 and negative 4. Now, again, like before, I've told you, you have to check to make sure that your answers don't make it 0 or negative inside the logarithm. Now, if I take that negative 4 and I plug it in here, I get negative 20, which means I'd be log base 10 of negative 20, which is not okay. So negative 4 does not work, but if I check on the 5, it does work. Okay? So, again, and I see this all the time, it's going to happen on tests. You guys, you have to get rid of that plus. You have to put them together as a multiplication using the properties.